Hello student, welcome to our physics session, that is physics in a smart way. Just like we were doing in the last three lectures, we considered another Maxwell equation in the simplified form. When I say simplified form, we say disregarding the physics portion of it. We try to explain it, we try to understand it, we try to comprehend it mathematically, purely how these equations are, whether they're tenable or not, whether I am able to realize or not, and if you are able to realize yourself a thing which is difficult to prove, then it is very difficult for your part, especially for physics point of view. So we got the equation that is integration b dot dA is equal to 0. So we got a current carrying conductor as we see in this case. Just a minute. We got a current carrying conductor. The current carrying conductor is shown in the figure. And so far as our basic knowledge of the current carrying conductor and magnetic field around it is concerned, we know around a current carrying conductor, for simplicity, we have taken a straight conductor. The lines of forces, magnetic field lines will be concentric and coaxial circles at a particular spot, starting from a very small radius. They grow in bigger and bigger circles. So they are a set of concentric circles, and the same sort of circles is repeated for the other places also. So a current carrying conductor is encircled by concentric. We imagine so by concentric and coaxial magnetic field or concentric coaxial circles. If you imagine or if we visualize that each circle present a particular amount of magnetic induction. Okay. So that diagram, that conductor is placed in a different way. Here the conductor, the cross section that you are seeing, the current inside the conductor is cross. Cross means that current is going into, sorry, let me change the color, that current that I have shown, that is going into the cross section of the current is going into the conductor is normal to the plane of paper or to the plane of your mobile, the plane of our computer screen. So current is crossing, that is going into. So around the conductor, we have circular kinds of forces, all those concentric and coaxial circles, just like you are seeing this diagram. So we consider a Gaussian surface-like surface here. A Gaussian, of course, it is difficult. The Gaussian surface, the Gaussian, the thing that we consider, this conductor, of course, we do not consider a stout conductor. We consider a thin conductor. That will be crossing the so-called Gaussian surface at two places. That will be crossing the Gaussian surface at two places, two different places. Okay, and we know magnetic lines of force, a particular magnetic lines of force is shown. So if you consider a particular dA of the Gaussian surface, we know a particular elemental area, dA, the dA will be normal. And because this is a circular, the center of the so-called Gaussian surface that coincides with the conductor axis. So thereby, we know magnetic induction will be tangential. Angle between B and dA, angle between B and area will be 90 degree. So if you start to write, if we start to go for our derivation, we clearly understand the closed surface integration of B dot dA will be the closed surface integration of B magnitude, dA magnitude into cos 90. Everywhere, any dA you consider, that will be cos 90. And because cos 90 is 0, so thereby that will be equal to 0. Okay, and with a bit of thought, with a bit of increase in our imagination, we may be able to think you may be able to realize that if I consider a surface, a closed surface, which is not a spherical one. We have proved a spherical surface here. We have proved a spherical surface. For a spherical surface, anywhere you consider dA, V will be normal to the dA, and because cos 90 effect is there, that will be 0. If you take a non-spherical surface, even if in some cases the B will be crossing the surface like this, in some cases is like this outwards, in other places that will be inwards. So thereby, we'll be seeing that those BDA, 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 or BDA cos theta, BDA cos theta will be cancelling out. So think clearly whenever you are thinking a physical case or a physics case or a physics question or a situation as divided by physics. Don't consider the rules and regulations and laws to inhibit your thought. You must allow your mind to go free. In this case, I am giving the job to you. If the surface is non-spherical, how we can have the same result, the integration of ETA equal to 0. So there, our basic aim, ladies and gentlemen, was to establish that a junior student of science, which means class 12 level, or engineering, that is class 13 level, is able to realize the so-called, the famous or formidable Maxwell equations, and that too without the help of physics, with the help of mathematics only. That was the basic job, to remove the so-called fear consciousness from you and to remove those bad ideas. In fact, sometimes I tell people that learning nothing is always better than learning a thing in a bad way. Learning nothing is always better than it's learning a bad thing or learning a thing in a bad way. You may be able to realize it. You may be able to realize it. The way our books, the way our teachers nowadays, as I am seeing the present scenario, they just try to deal with physics and deal with students like this. You call the formula. You just remember them and you try to find out. Just like for my example, if a student is dealing with a case of constant acceleration, so then teacher says that you got 3 or 4 formulas: V equal to U plus AT, S equal to UT plus RBT square, V square equal to U square plus twice S nth equal to U plus A by 2 to N minus 1. You got these 3 or 4 formulas. You just take any question and try to find out using these formulas. Using the formulas, answer will be coming out. No, it's not. If I encounter that teacher, my answer will be no, sir, you better do not teach. If you are not able to teach the spirit of the physics, or the scope of the physics, or the history of the physics, or the philosophy of the physics. Physics is not just a set of formulas, it is a philosophy. It has to be understood, and we must allow our mind to go free, to run wild, without the inhibition of the formulas and all that. So thank you. Our next class, we shall see what you can do. Please like, if you like it, of course, if you like it, share and subscribe my videos if it is helpful.